I think we had basically some productive discussions. Darren made some progress on some of his stuff, and do any of you want to share anything before we dive into, the coding session?
No, I had an idea basically, like I think
Mm-hmm.
a couple of meetings ago, and how I want to like solve this problem
Mm-hmm.
was the um, uh, with explainability models,
Mm-hmm.
but I haven't done a lot of coding on it yet, so that's what I was thinking of
Okay.
doing.
Okay, that's fine. So why don't we dive into it? I'm a little sick today. So yeah, I've been a little sick over the weekend and canceled hands-on ML homework session as well. So yeah, yeah, I'm a little slow today. Bear with me for a minute. In um, so let's dive into the session today, and coding session, and we'll talk, maybe in an hour or so. See if you guys want to share anything.
Yeah. So I'll have to leave the meeting in 45 minutes
Okay, got it.
for meeting, but usually they last short. So if it gets completed early, then I'll join back again if this is live.
Yeah, that sounds good. Yeah, 12:15. That's the time. And since it's just three of us, I'm not gonna, have breakout rooms. So yeah.
So yeah, so I think I might like disconnect and then connect back.
Okay,
Um,
that sounds good.
so
Yep.
all right,
All right. Talk later.
okay. Bye. Hey, Wenchang.
Hello, Yuri.
Hey. So I have a question.
Yeah.
So I don't know if you heard that Google went down this morning.
Yeah, I
all
heard about that.
services.
Yeah.
So I was wondering if that's a reason for my problem. So I'm trying to like look at a lot of code examples, like like a Medium and those data science articles, and all of them. So it's either my problem or a problem of the browser. In almost all of them, the code examples do not show up. Like they show up as like a garbled. I'm assuming they came from notebooks.
Do you want to send me the link?
Yeah, let me.
Yeah, send me
I'm
the
trying.
link.
Yeah, I'm trying on the same thing on another browser now. I just realized that I can change the browser also. Yep, same problem.
Send me the link.
Yep. That's just one of them.
Are you saying the code in the? Oh, yeah, it's same thing for me.
Okay, so I think it's one of the because it's probably like a collab hosted, or it's hosted somewhere probably. Not collab, but like.
Well,
The thing is,
no, it says GitHub.
Oh, it's GitHub.
Mm-hmm.
Oh, okay, so maybe it's a GitHub problem.
Mm-hmm. Yeah, I would say so.
Yeah,
It
this
has
is
a
the.
href to GitHub. Yep, it's just GitHub gist.
All right, so I
Yeah.
was successful today because I couldn't steal code from GitHub. But I kind of realized that for what I wanted, so ultimately, I actually want to use LIT because I actually want to use it for work.
Yeah.
But for this specific competition, Lime is probably good enough to start because I really don't need it. I don't need like a visual component.
Right.
I just need to like run it.
Yeah.
So I'm trying to like use examples where just Lime is used directly.
How do you interpret this model with Lime? I'm curious.
Oh, so the idea was, so in this competition, the mapping was done manually, right? So somebody read all the tweets and said that's positive, that's negative. So what I was thinking is taking just one of the pre-trained. You can actually train the model, or just use one of the tweet classifier models, which like are very like abandoned. There are a lot of them that exist. Like actually, LIT comes with one. This is how. Well, maybe let me see if LIT is running. Maybe I can show it. Yeah, if you have a second, I can show it now.
Yeah, absolutely. You can share the screen, right?
Yeah.
Yeah. Yeah.
I'm not sure. Like, so the names do not come up.
Oh, there you go.
Tell me what you see. Do you see the tool?
I see a white screen.
Oh, that's not it. Because when I'm picking screen, I do not see what I'm sharing.
Oh, there you go. I'm seeing LIT. Let's.
So do you see like panels?
Yeah, LIT dashboard.
Okay. All right. So this is specifically, so this is one of the examples running on the server. It's the model is SS2 Tiny, which is trained on SST, which is basically sentiment analysis standard from Stanford. So you can see it's a charming and often affecting journey. Label is 1, which is, I guess, positive. And then if you come down to the lower panel and look at explanations, and you look at explanations, then let me expand all of them. So they use gradient times input. The first two, actually, gradient times input, there's a presentation by from empirical methods. They kind of go through different methods, and they use gradient, basically like gradients as an explanation, and gradients time inputs as an explanation. But like before, I looked at that for this specific problem, the Lime was better. But see, you can see basically what's contributing to the score. Well, this is negative, slow. So if I click on positive, you can see which word contributed.
And this is sort of like attention, right? I mean, but
no, attention is on the right.
attention's on the right. Okay,
so
but what?
there are like so there are 4 different scores here. So Lime is this local explanation.
How do they get that?
And then the first three are you can get them from TensorFlow itself, I think, from gradient time inputs. So basically, like I guess it's how well it's changing, sort of like in that direction.
Yeah. How do you actually calculate these 4 things in the middle?
So it's calculated for you, right? So Lime is a package. Lime is like a local. They do like a local. They build local model in that vicinity. That's been built, I think, long time, 3 years ago at least.
So Lime, what is Lime using again?
Lime is it's not for NLP. It's for any model, and it's not for and it's not for neural networks only. It's they call it local interpretability. So it's I think they build like a linear model, but in the local vicinity of that space. So what I can do is just a second.
And which one is performing the best? I mean, from the salience maps, seems like Lime is okay. But what about the other 3 integrated gradients, gradient dot inputs? What are the other 3?
Just a second. Let me show you. I just need to load the data. Oh, sorry. All right. So this is from this data.
Yeah.
So we're analyzing this new data point. And this is negative. I guess label is negative.
You got a call?
Yeah, just a second.
Yep.
Yeah, so it's negative. You can see here at the bottom, Lime kind of interprets it well. So I guess so sad biggest contributors to it being negative. And if you look at gradients, it's actually look at tokens, right? So
what are these three?
So that comes from the network analysis itself. There's a presentation from the guy. I kind of listened to it, but I didn't look at details. The first three are basically once you have neural network itself trained, you calculate gradient norm at that input. And there are like two techniques. One is gradient norm, another is gradient norm times input. And that gives you the score, how well it can, the contribution to one or the other answer. I didn't look at the, so on the right, there's attention. So I guess the
attention doesn't seem to show much.
Yeah, attention is more difficult to interpret, so I didn't want to do that.
Yeah.
So I was thinking basically Lime is the easiest to use because it already has like sentences. So once I have Lime, but Lime gives me answer for everything, but we need so I need a span for the answer. So then I can solve this computer. There's like a famous computer science interview question. Find the span of the array with the maximum sum, or lowest minimum sum in this case.
Yeah, I mean, I guess, maybe yeah, then you just program a function, right? Find if it's negative, if it's zero label, then pick all the continuous negative.
Yeah, there's actually there is a function to there's like a algorithm how how to pick the span.
Oh, interesting. What's it called?
It's called Cadane.
Cadane. Okay.
Yeah, it's a good interview. It's a standard interview question.
Interesting. Okay.
Yeah. So I was thinking of like doing that, but I haven't programmed anything.
Cool.
But yeah, I kind of like, so this was useful because I after I looked at it first time, I actually like saw what the gradient norm and gradient norm like time inputs are. So actually, maybe interesting to use them also.
Yeah. Yeah. Understood.
See which one comes. All right.
Cool. Very cool. Yeah. No, I wanna use this as well because seems to be very cool, and I want to dig into more of how Lime works on the back end, because it seems like it's model agnostic, and I'm just so fascinated by that.
Yeah. So Lime and Shap actually is the other tool that's sort of universal.
Yeah.
It's like a Shapley implementation. So they don't have it here.
Yeah. Seems like that is one creative way to do this project. I don't know. Yeah. I'm looking forward to.
I don't think it's going to give me like a highest answer, but I was more interested in actually like learning the tool.
Yeah, absolutely. Let's do it. Yeah. And Parth, do you want to share anything?
No, that's it. Oh, Park.
Yeah, yeah,
Sorry.
yeah. No worries. Because I saw Park joined.
Yeah, I had a question on that. Is that tool free to use?
Yeah.
Yeah,
Yeah.
it's free. It's open source.
Wow, and I didn't know about that. That's
Yeah.
interesting.
So yeah, so it's from Google. The only thing it's sort of like you know how Google. It's been on Google AI blog, but you know how with Google you never know which projects are enthusiast projects and which ones are like fully supported. So
Right,
I
right.
think it's an enthusiast project.
Yeah.
But it's the area where a lot of people are doing stuff. But they have like basically you can build your own. They tell you how to basically use it for your own model.
Yeah.
So in this case, I was going to just use this SST2 Tiny, but or like some other like a similar model. But you can actually use any model, and they let me share it again. So they basically say how to like add your own model and data. You need to implement few classes.
Cool.
It's actually built on. Oh, I guess they build it both on Keras and PyTorch.
Very nice.
Cool.
So you can use any model from the what was the model you were using?
So I didn't use my own model. I just so this is the online example,
Oh,
and they have several models. But the first one is actually what is exactly. So there's several links. I think from here there's sentiment analysis, masked word prediction. Those two are running all the time, but I think in their examples they have more. But yeah, here they use a model called SST2, which is Stanford Sentiment Tool. And it's a small bird, like a small bird trained on it. Okay, you can look at data set. Stanford Sentiment Tree Bank. But basically, you can build your own model. This is what they're saying is you need like create your own like demo py launcher and implement two classes. And you should be able to interpret your own models.
Cool.
Yeah.
Cool. Yeah.
interesting. Yeah. Well, so I was just going through. So since we were taking the question answering approach, I was just following the tutorial. So since I'm learning transformers and doing it at the same time, so I'm just taking it very slowly.
Yeah, transformer is going to take some time to learn. Yeah.
So this tutorial uses Roberta, and so I was like 2 weeks ago, I was doing this tokenizer thing, which first step. So they use this byte level, like GPT-2. So so one of the thing that they added was add prefix space equals to true, and I was very curious, like what it means. So through that documentation, it didn't explain me very well. So I had to dig in a little deep, and that I learned a lot through that process. So did I share? I think I shared it with our that room, but it's a very interesting concept. Maybe you guys know it though. It's
I don't think you shared it, but yeah, feel free to share now.
okay. Yeah, I can do that. You guys see the screen?
Yeah.
Yep.
So yeah, so this was the thing that they add prefix spaces equals to true.
Cool.
So that led me to explore things like when our sentence is like this, what is up with the tokenizer? So byte level tokenizer splits into these tokens. But the interesting thing is you see the special characters G, which is the space. So here this for the tokenizer, space is actually considered as a part of the token. So so if it's a sub token, it doesn't add a space. But if so up, it considers the space as part of the token, with as a part of the token. So this leads to inconsistency though, because if you notice, the first token will always be without a space, because there's no space ever before. So this leads to inconsistent results, which was proved on a blog. So when you do text as cats are super coolio and next text is super coolio, you would expect their ending tokens would be similar, but actually when you encode them, they are not. So here it's 1610130 and here it's 24223035102 and 2. So it's because here the super is with a space and here the super is without a space. So that leads to inconsistency. But when you add the prefix space, set it to true, then you see consistent result. So, but the thing is, which is surprising, is there's a trade-off. Uh, this definitely improves your tokenization, but surprisingly, it leads to slightly lower performance. Yeah. So I'm not sure what the logic behind that is, but someone wrote that it's because the models were trained this way. So
and where is tutorial from?
this is I was just simply following this tutorial, TensorFlow Roberta.
Got it. This is this under the project? Oh, this is okay. Cool.
Yeah, so I was just since I was trying to learn, I was curious why.
And does the notebook have a better results than maybe just entity recognition?
Oh yeah, I think so. Here the score is 0.70. And I think with Spacey NER it was around 0.63.
0.63. Wow. Okay. 0.63 is not that good. Yeah.
I did Flare, but I think I wasn't able to. Since this is a kernel submission notebook, I wasn't able to do Flare.
So QA seems to be the way to go, I guess. Is that one of the highest scores?
I think so, because most of the notebooks are question answering notebooks.
Wow. Okay.
Yeah, I would definitely, like, if I were like try to like solve it for higher score, I would look into a QA and specifically like I guess they call them it's like a pointer techniques, where you basically like give me the first point and the last pointer of the answer.
Yeah.
And
why
then
model
QA,
any rationale behind why QA is performing so much better?
I'm not sure. Maybe it's just the like I don't know if we use the same model, let's say a BERT model for an identity NER in an NER way. I don't. Maybe someone has tried it, but I haven't seen. I would expect to give similar performance, but I'm not sure why.
Because in a sense it is a classic like a question answering problem, right? Give me span of text that answers my question. And
what is the question in this context?
And my question is, what led to positive answer? So actually, I don't remember now where I saw this, but so it might have been in the I don't remember if it was in CS224 or it was somewhere else, but like recently I saw a presentation where somebody basically they postulated all the NLP problems as question answering problems.
Yeah. Well, that's interesting. So my guess is so here the text that we have column is the context. The selected text is our response, and sentiment is our question. So
Yeah, question is like,
yeah,
why is it positive?
why is it positive?
Question is the sentiment. Okay.
Yeah. So why is it positive? And so the model will extract response from this text, which is the context. And
So with Roberta, you don't even have to have an actual, question. You just literally pick a column, and that's your question.
yeah, there's a certain formatting, like they instead of picking column, they want in a certain format, which they have done it here, but I still have to look. But yeah, I think there's certain they want in a specific format, which I'm not sure yet.
Wow. So literally, you can just pick a column or use your label as the question.
Yeah.
To be exact, and pick whatever text within your data as the answer. Wow, that's pretty interesting.
Yeah,
cool.
so yeah, that's what I've been doing.
Cool. Yeah, I gotta dig into that as well. Cool. Thank you guys for sharing all the great stuff. And I'm almost like I'm going through the NER model right now and trying to interpret the results and go from there. So yeah, I'm a little slow because I've been busy on other projects for work, but slowly getting there. So yeah, cool. Thank you guys for attending the sessions. Really appreciate it. And so I'll talk to you guys next week.
Thank you.